Common vegetable crops of Alaska. This presentation was created through a collaboration between the Alaska Association of Conservation Districts and the USDA Natural Resource Conservation Service. If you've got questions on any aspect of the presentation, please contact the conservation planners at your regional NRCS office. The USDA Agricultural Statistics Service recognizes the commercial production of about 50 vegetable crops in Alaska, ranging from potatoes to watercress. In the chart, areas with 0 acres listed have less than a half an acre, so the count was rounded down to 0. Here's the list of Alaska's 12 major vegetable crops grown outdoors: potatoes, carrots, broccoli, squash, cabbage, lettuce, cauliflower, green beans, and snap beans. Potatoes by far are Alaska's leading vegetable crop. The total acreage of potatoes is almost 10 times that of the number 2 and 3 vegetables, carrots and broccoli. You can also see that Mat-Su leads the state in the production of most vegetables. One of the exceptions is that the warm season beans grow better in Interior's warm summers than in Mat-Su's cooler climates. As you'd expect for Alaska, most of our field-grown vegetables are classified as cool season vegetables. The only warm season vegetables on the list are squash and snap beans. Alaska's major list of field vegetables breaks down into 4 major production groups: crops that are produced through vegetative propagation, like potatoes; crops that are direct seeded, like carrots; crops that are primarily transplanted, like cauliflower, cabbage, broccoli, greens, kale, and lettuce; and the warm season crops, squash and snap beans. Potato is a vegetatively propagated crop. Alaska has 3 potato industries. The fresh market potatoes, also called table stock, these are the potatoes grown for table consumption. Processing potatoes, these are the potatoes grown for becoming potato chips. And seed potatoes, potatoes grown to become seed for the next growing season. Seed potatoes. The true seeds of the potato, the cherry tomato-like structures that you find on the plants, are not used on a commercial basis. Rather, the product called seed potatoes are tubers grown to strict standards to ensure that the producers using them for processing or fresh market will plant known materials with low disease levels. Seed potatoes are cut into 2 to 4 ounce pieces, and these pieces are what's planted. Once planted, each seed potato piece will grow into a plant producing 1/2 to 3 pounds of potatoes for the market. This huge range in production primarily depends on the soil conditions, the weather, and the presence of irrigation. The Alaska Division of Agriculture inspects the seed potato crop in the field and while it's stored, looking for insect, disease, and varietal issues. Processing potatoes. In 2020, only 1 commercial potato processor operated in Alaska. The Alaska Chip Company purchases processing potatoes that have been bred to optimize chipping characteristics. Potatoes grown for the processing market are usually grown to tight specifications set by the processing plant. These include uniform size, high starch content, low sugar content, and very exacting storage conditions, very tight temperature control, very tight humidity control. While restaurants and other commercial kitchens process large volumes of potatoes, they primarily use table stock varieties rather than processing varieties. Fresh market or table stock potatoes are by far the largest vegetable crop in Alaska, both on an acreage basis and on a market value basis. Potatoes by far are the most mechanized crop in Alaska. For the larger growers, the crop is hardly touched by hands at all. Potatoes have the most specialized storage. Temperature controlled is often within a degree of the desired set temperature, and air movement and humidity are also very tightly controlled. Potatoes are a very high-value crop on a per-acre basis. Crop yields range from 5,000 to 50,000 pounds per acre. Selling prices range from 35 cents a pound on the wholesale market to up to $2 a pound at the retail value for specialty potatoes sold on the farmer's market. For typical potato operations, the soil is prepared in mid-May, and the seed potatoes are planted in late May to early June. Fungicides may be applied to the seed to control Rhizoctonia, Fusarium, or Sclerotinia. If herbicides are used, they're usually used as a pre-emerge. The crop is cultivated or hilled in late June to early July. The crop is irrigated throughout the season as needed for yield and quality. In some cool wet seasons, foliar fungicides are needed to control late blight. Some growers vine kill in August to harden the skins prior to harvest. Harvest usually starts in September, and the crop is put directly into storage. Potatoes will be sold out of storage from October until the following August. Fertilizing for potatoes. Potatoes are a very high-demand crop that rewards proper soil nutrition. The recommendations used in Tech Note 16 are based off of the UAF CES publication, Field Crop Fertilizer Recommendations for Alaska Potatoes. The target pH for potatoes is 5 to 5.4. These mildly acidic conditions are primarily to manage potato scab, since scab does not prefer the lower pHs, but the potato does grow well at these lower pHs. For red and white skin varieties, UAF recommends 80 to 100 pounds of nitrogen at planting. For the russeted varieties, use 120 pounds of nitrogen per acre at planting. Be sure that the applied plus the residual nitrogen doesn't exceed 175 pounds of nitrogen per acre. For potassium, low potassium levels, 0 to 75 ppm, warrants 180 pounds of potassium per acre. Medium potassium levels, 76 to 150 parts per million, warrants 120 pounds per acre. High levels of potassium, 150 to 300 parts per million, warrants only 60 pounds, and over 300 parts per million, there's no need to apply any potassium per acre. For phosphorus, the application rate ranges from 80 to 300 pounds per acre of phosphorus as P2O5, depending on the soil series and the levels of residual phosphorus indicated by the soil test. Please refer to the UAF publication, Field Crop Fertilizer Recommendations for Alaska Potatoes, for detailed charts. Secondary and micronutrients are usually not a problem for potatoes, but the UAF publication has additional information on these topics, as does their other publication, Plant Tissue Testing. Some growers think that these university rates are too conservative for the modern production yield goals. Carrots are Alaska's major direct-seeded vegetable crop. Carrots are direct-seeded because their roots do not tolerate any disturbances, so they don't lend themselves to transplanting. In order to grow a marketable crop, carrots have to be direct-seeded. Commercial carrots are characterized by root length. The short root, round or thumb-type specialty carrots. The medium root, the Nantes type, is the most commercially grown or sold, and the long root, the Imperator type, which needs extra deep soil. Almost all carrots grown in Alaska are sold on the fresh market, since the few commercial processors are relatively small and don't demand high tonnages of crops. Typical carrot operations. The soil is prepared in May, disked and formed into raised beds. The carrots are seeded in late May to early June. If herbicides are used, they're usually pre-emerge herbicides. For small-scale production, they may be thinned out by hand to 1.5 inch spacing. Small and/or colored varieties will be dug weekly for the market. Storage, primarily the Nantes types, will be grown as long as possible in the soil. Harvesting on the small scale, the crop is dug by hand using a digging fork. On the medium scale, The crop is dug using an undercutting blade behind the tractor to lift the carrots for easier picking. On the larger scale, the carrots are lifted from the soil by the foliage. They're harvested just before the ground freezes, so they get the maximum growth in the field, and they're put directly into storage. The carrots will be sold out of storage from October until the following August. Lettuce is an example of a transplanted crop. Transplanting vegetables wherever possible has taken place of direct seeding because it takes advantage of the greenhouse during the late winter to early spring. The crop germinates sooner in the greenhouse than outdoors because of the warmer temperatures. The crop is in the greenhouse while it's still small. The flats that are used are very high density, ranging from 96 to 300 plants per flat. The transplanted crop is more uniform than a direct seeded crop, and there's no need to thin a transplanted crop because it's planted at the desired spacing level. Larger operations are very mechanized for their transplanting. You also get better weed control, since the transplants will shade the soil sooner, blocking the light to the weeds. The crop is already 3 to 4 inches tall when the weeds start to grow. To ensure a constant supply of product for market, some farms will be transplanting weekly from mid-May through July. Essentially, with transplants, money buys time. Lettuce operations. The soil is prepared in May, disked, fertilized, and formed into raised beds. The crops are transplanted on weekly intervals from May to July to ensure a constant supply of top-quality produce for market. On small-scale operations, the lettuce is transplanted by hand. Paper pots and other small-scale techniques are also used on small and medium-scale operations. Large-scale operations use mechanical transplanters behind the tractors. These transplanters range from 1 to 8 rows wide. While some herbicides can be used before transplanting, weed control in lettuce is primarily through cultivation, with hand hoeing often being a significant expense. Irrigation is important for both yield and quality. Depending on the wind and air temperatures, irrigation can be necessary up to 2 to 3 times a week. Lettuce is hand harvested and handled according to good agricultural practices and good handling practice protocols. Lettuce is chilled as soon as possible to maintain quality. It's usually down to refrigerated temperatures within hours of being pulled from the field. Squash, Alaska's warm season vegetable. Alaska squash production is almost exclusively for the fresh market since there's only a very small processing market. Squash production is unique because it's a warm season vegetable. The soil is prepared in May, disked, and formed into raised beds. The beds are covered with plastic mulch. This mulch is either laid by hand, or the mulch is applied using a mulch layer behind the tractor. The drip tape is installed under the mulch to supply water for the crop. The crop is then transplanted right through the plastic mulch. The elevated soil temperatures from the plastic mulch allow the warm season crops to grow that otherwise wouldn't produce in Alaska's cooler soils. Some growers also use the clear plastic over the crop to create long, mini greenhouses in the field to improve the yield. These are called low tunnels. When the crop is ripe, the low tunnel covering is opened up to allow access for harvesting. Most of the horticultural plastic used is single-use only, so plastic disposal is an issue. Making vegetable nutrient recommendations. As with all crops, the foundation of growing vegetables economically in Alaska is maintaining the optimal conditions for crop growth. Meeting the anticipated nutrient needs of the crop starts with determining the level of nutrients that are already in the soil and then supplementing with appropriate nutrient sources to meet any needs. Step 1. Collect a representative soil sample. Step 2. Send the sample to a lab that uses appropriate analytic procedures for Alaska soils. And Step 3. Use University of Alaska recommendations to meet any deficiencies identified in the laboratory results. The statewide nitrogen recommendations given in Tech Note 16 come from University of Alaska Fairbanks research. For nitrogen recommendation, red and white potatoes are grouped with general vegetables. Russets, on the other hand, get a bit more nitrogen. Unfortunately, these recommendations are not refined on a per vegetable basis for commercial field production. Rather, all vegetables are lumped together. When we look at the statewide potassium recommendations, we see that all the vegetables and all the potatoes share the same potassium recommendation. The differences between the high yield goal and the average yield goal recommendations show up in the 150 to 300 part per million range. Within TechNote 16, the phosphorus recommendations work differently than the nitrogen and potassium charts. All soils low in phosphorus get 200 pounds per acre of phosphorus. All soils that are medium in phosphorus get 150 pounds per acre of phosphorus. All soils that are high in phosphorus get 100 pounds per acre of phosphorus, and all soils that are very high in phosphorus get 50 pounds per acre of phosphorus recommendation. The big difference is that different soil types have different breakpoints between low, medium, high, and very high. So, on a Matanuska soil, a soil test result of 75 parts per million would warrant a 200 pound per acre phosphorus recommendation. But on a Jarvis or Copper River soil, a 75 part per million analysis would only warrant a 150 pound per acre recommendation. These differences between soil types are primarily due to differences in volcanic ash contents of the soil. This volcanic ash binds the phosphorus, and hence we have different recommended rates. As you can see, if the grower has average yield goals, the part per million breakpoints are the same, but the low, medium, and high recommended rates are each 50 pounds per acre lower than the recommendation would be for a high yield goal. To summarize this talk on Alaska vegetable production, weeds are primarily managed through cultivation, although herbicides are registered for some crops. Depending on yield and how the crops are marketed, vegetables can gross between $10,000 to $40,000 per acre. Specific extension recommendations exist for potatoes, but they're not up to date for current production levels. TechNote 16 has general vegetable recommendations for gardens and high tunnels, but not for specific vegetables grown on the production field scale. And importantly, with Alaska's relatively dry summers, irrigation is critical for yield and quality. Thank you very much, and please contact your local USDA NRCS office with your Alaska vegetable production questions.